All right, everybody, welcome to part 3 of the review sheet, greenhouse effect. So I've got a greenhouse here drawn, right? We're going to do a drawing that I know you've seen before, but let's do it one more time. Shortwave energy, the stuff that comes out of the sun, like visible light and the ultraviolet radiation that we want to protect our skin from, has no problem traveling right through the glass of a greenhouse. And it gets down to the greenhouse and hits stuff, and then that stuff warms up. And when it warms up, just like that camera that we passed around in class, that infrared camera, it gives off a longer wavelength of energy. It gives off heat energy. And that is infrared. That's heat energy. Right now, all of you are giving that off to the room, and we detected it with that camera that we have. Infrared. Whereas the incoming solar radiation is more, again, visible to ultraviolets. And that's it. That's the trick. This stuff can go right through the glass. This stuff can't. So the net result is that the heat energy that's given off by the objects inside the greenhouse get trapped by the glass of the greenhouse. If you have one, it's a good idea to put heat sinks in your greenhouse. So, I mean, and it doesn't have to be something fancy. A water jug or a gas can that you paint black and fill with water does a great job. Think about the properties of water. We have to do that in a minute down below. Water's hard to heat up, right? But then it holds its heat. So if it heats up all day in the sun and then gives off its heat slowly throughout the rest of the day, that will keep your greenhouse nice and warm. All right. Why are we talking about greenhouses? Because, and we're going to do it again, the same drawing. This mimics how this works in our atmosphere. Our atmosphere allows the shorter wavelength of radiation to pass right through. Yes, some bounces off the tops of clouds and even off the top of the atmosphere and doesn't make it all the way down, but a decent portion does. And when it hits the earth, surprise, surprise, it heats it up. There's the purpose of doing all of those absorption labs. When something's in the sun, it gets warm, right? No surprise. The trick, and again, if you type this into Google Images, you'll see bad drawings that will show the same wavelength coming out. That's wrong. That's a reflection. And if it reflects, it would just go out the atmosphere just as easily as it came in. So that is not the way to do this. I'm erasing it, hoping you're listening. The way to do this is that the Earth heats up and then gives off that infrared energy, that heat energy, but that heat energy gets trapped in the atmosphere by greenhouse gases. Instead of the glass of a greenhouse, it's the gases that do that are good absorbers of energy. So here's a slightly new little trick. Here's one thing that you're going to need for the test tomorrow. What are the greenhouse gases? We didn't really mention that yet. The test is Friday, by the way. Carbon dioxide, methane, and water vapor. Now, we can't really control water vapor. There's going to be some in the atmosphere no matter what, right? Depending on the region, the climate, all of that. Methane and carbon dioxide are naturally in the environment for sure. They come out of volcanoes. They've been here longer than humans. But if humans go and add too much of this, every time that we burn a hydrocarbon, any sort of fuel whatsoever, you're releasing carbon dioxide as a byproduct. And that enters the atmosphere, and that's a more efficient absorber of that infrared radiation. Methane, same deal, only methane's a way, way, way more efficient absorber of infrared radiation. So humans adding too much of those first two is leading to an eventually slowly warming climates. Okay. Now, that is a tiny bit of new info, and there's one other bit of new info we're going to do below. But I think you'll do a good job with it. All you got to do is be able to recognize those two. Maybe in multiple choice questions, maybe it'll be like, here's two greenhouse gases. What's the other one? All right. Yeah, next one's next. Good job, folks. Keep up the fight.